Hey folks, I've been very busy with Python and that's what I'm going to talk about this week. So about a year or so ago, decided that I wanted to embed Python scripting into my game engine, and I did it. And the library I used to do it was PythonQt. As we can see, right here is the main website for PythonQt. And that had been serving me well enough for a while. And over the last few weeks, I started investigating another library called PyBind. And I just wanted to chat about what I've learned. And if you want to get the Cliff Notes version and not listen to the whole video, it's pretty much that PyBind seems to be a much more modern framework. It seems to be a much more user-friendly framework. It's certainly a much lighter weight framework. And it's just generally easier to use and I think more flexible. So I've been migrating all of my Python bindings from a mix of PythonQt and the raw PythonC API into PyBind, and I'm still keeping some of the raw API calls, but PythonQt is no more. And I'm going to talk about why I made that decision, and hopefully it'll help some of you guys make similar choices. So I'll start by saying that PythonQt, as the name would suggest, is dependent on the Qt framework. So if you're looking to use it, you're going to have to use Qt, no way about it. And that is because PythonQt leverages Qt's meta system for objects. So it takes a lot of the type information that you get with some of Qt's built-ins and macros in it, and it uses a lot of that. So it's very dependent on Qt. Whereas PyBind is an entirely standalone library, and moreover, it's a header-only library, so it's super easy to install. And that was one of the reasons why I actually didn't end up using Boost Python about a year or so back, because I just couldn't figure out how to get it installed with QMake. Now I've migrated over to CMake, so that wouldn't be an issue anyway. But PyBind is very easy to install. It's a very similar API to how Boost Python works, except it's lighter weight and it doesn't come with any of the extra other stuff that Boost comes with. So if you're just looking for Python bindings, PyBind11 is the way to go. So I'm not going to get into the details of all the specifics because PyBind11 actually has very excellent documentation. But go to the website, read it yourself. That is one of the primary reasons, and I'd say second only to the fact that the API is so elegant as to why I'm switching over to PyBind, is because PythonQt is incredibly limited when it comes to documentation. You get a few pages on the website, which are pretty much just class API summaries and the auto-generated docs, and that's about it. There is a forum on SourceForge that looks like it's migrated over to GitHub for PythonQt, but there's very little community support surrounding PythonQt and a very small number of active developers. I think actually only one right now. Don't hold me to that. But it's very difficult to, if you have questions on PythonQt, it's very difficult to get support. Not that those few working on it aren't passionate about it, but there's only so many people can do. And it's old, and it's just not very frequently maintained. So there is a very real concern that I have that PythonQt within the next couple of years is going to be unsupported and deprecated. So that's the second reason why I'm migrating over. And I'll sort of touch back on what I mentioned earlier, is that whereas PyBind11 is incredibly easy to build and install, PythonQt is very difficult to get installed. Like I said, it's very Qt dependent. I actually haven't been able to get PythonQt working with the CMake build at all. It may or may not be possible, but I haven't found any documentation online or support to get PythonQt working with CMake. So it was sort of just a no-go if I wanted to switch build systems. And it relies on some very old, very large, monstrous compilation code. I forget what the name of it was, but it was developed by the company that previously owned PythonQt, which might have been Nokia actually. And so I don't know how well supported that still is, but there's a lot to it. You have to run a generator that then generates bindings to use PythonQt. It's a whole mess. I will say that one advantage of PythonQt is that it does come with a lot of Qt bindings already built into it. So if you want to call Qt classes specifically from the Python side of your application, then that would be one reason to use PythonQt. But I will say that I think that would be a pretty rare use case, because you are either going to be using PySide or another Python package to wrap up Qt to actually build a Qt application on the Python side, as opposed to having a Qt C++ application where you bind Python code to it and then want to call Qt stuff from there. That's my 2 cents. If you really think that's a usage you want, then maybe PythonQt is the way to go. But it's also possible to wrap Qt stuff up in PyBind. It would just be a little bit more overhead. All right, which moves me to the sort of, I think the main justification for PyBind is just how much prettier the code actually looks. So I'm going to pull up and just do some side-by-sides here, or I'll do a before and after, so you can see just how much less code it actually takes to bind a class in PyBind compared to PythonQt. And I do want to add that I am in no way affiliated with either of these two libraries. I am just building my engine, and I'm really excited that PyBind is going to make my code a heck of a lot prettier. So what I have here is is some of the old code I used to have that I'm currently pulling out of my repository. For wrapping pretty much everything, I just lumped it all into one file and never really organized it. But I'm going to use my vector class as an example. So one real limitation of PythonQt is that it doesn't give you much in the way of wrapping template classes, and methods for that matter. So if you have anything that's templated, you're going to have to manually map each of those template specializations over into Python, which can get very tedious very quickly if you have a lot of specializations that you're going to want to bring over. So here I have on the left side it's just my header, on the right side is the source for the same code. So I'm just going to scroll down. So here's the start of my vector2 class on the left side here. Let me maybe make that a little bit smaller so we can fit more of it onto the screen. Do that over here as well. Maybe a little. All right, perfect. So start line 200 or so here, and so here I'm defining. I just have a class name, so you can access that, get that metadata. I have constructors, destructors, all of my operator overloads. You'll notice, so the API pretty much, you just take the name of what the function would be in Python, and then you override that on the C++ side. That is effectively how PythonQt works, but once again, there's really no documentation that makes it clear that this is how you actually wrap things up. It took me so much Googling to figure out how to actually do a lot of this. I didn't even know that you could do operator overloading on the Python side from C++ until I posted on the forums and was like, hey guys, like, has anyone tried this? And you have to sort of, dig really deep into the source code to be like, oh yeah, that is a feature that's in there. And then I'm overriding some of my vector math. So this is for a vector 2, so just a vector of 2 elements. My vector 3 has some fancier stuff, because then I override the same operators, and then I also do some stuff to add cross products, dot products, stuff specific to 3-dimensional vectors. But you'll notice that I have to just redefine all of this stuff every time. So I'm just scrolling through it. I end up with about 250 lines or so of just header code for defining the vectors, and then another few hundred lines for the actual implementations of those methods. So let me just search here, find the end of that. Vector 4. All right, so this ends up being about 300 or 400 lines of source. So then, all right, so 600 lines of code to to wrap my vector class for Python. So that's not, it's not the most code, but 600 lines is a lot, right? So it gets tedious, and especially when you're weighing that along with the fact that it takes so long to dig through the documentation to actually figure out how to do a lot of this stuff, it ends up being pretty painful. And so that is why I was very pleasantly surprised to see how much easier it is with PyBind. So PyBind, I pretty much just opened up their online docs, and I'll do it right now. I went to their online docs, and I just went to their subsection on the side here that said they have a classes section and an object-oriented code section. Object-oriented code covers most of the basics, and then classes gets a little bit deeper into some of the specifics of some of the weird stuff you might want to do. But it's all here. How to do it all was all here. I didn't have to ask anybody. I didn't have to go crazy Googling anything. It was all on one page. So that was a huge time win. If code is well documented, people are going to want to use it. Case in point. So here is what the actual bindings look like for my vector class in PyBind. 100 lines. That's it. And that's with some of my own comments, doxage, and wrappers. Because I can actually use templating here. So I don't have to go reinventing the wheel every time I want to specialize. So what I do is I have a create method. What PyBind lets you do is it lets you take either static functions or they don't have to be static functions, lambdas, you name it, and then you can use those and wrap those to automatically send them through PyBind, and PyBind has the sort of meta programming, the templates to wrap that up and know how to pass that to Python. So it really saves you a ton of work, because not only is the API cleaner, but it's also smarter in what it knows about your classes. So I can just pass it a function handle, and it knows, okay, this is what I'm expecting out of it, this is what I'm expecting into it, and as long as I have Python binding for the output type, which in this case would be some template specialization of my vector class, it'll know how to connect all the hooks to just be able to use that in Python, which I thought was really cool and really surprising, considering that PythonQt relies so much on Qt's meta object system to do what it does. I was really impressed that PyBind can do all of that without having any sort of other dependencies. So that was really neat. So yeah, there you have it. I'm doing all the same stuff, and it looks a lot cleaner. I just add a few constructors, which is done by calling this PyInit routine from PyBind. I template it to take 2, 3, or 4 arguments of type T. I give it a copy constructor. I give it that factory function constructor that I have that I just showed up here. That's a one-liner. So many one-liners for just wrapping the code. It's really so elegant. I have a lerp that's defined in my vector class. Once again, templated. Just wrap it up in one line. And then I have a bunch of lambdas for things that the types didn't quite match up with my C++ functions. So I just gave I added some translation code to convert Python objects into C objects. A Py object is just a very lightweight wrapper around a Py object. They're called the same thing, but the actual C API Py object. So PyBind is really nice because it has a lot of one-to-one mapping with Python C API. So if you're familiar with that, it's going to clean up a lot of that code and just present things in a way that's much more user-friendly. So there you have it. You can do everything, like I said. You can do static methods too. I don't think I define any properties for my vector class, but you can define properties. I never figured out if I could define properties through PythonQt. I think you maybe just can't. So I really didn't find anything that I couldn't translate over into something that was very Pythonic. So yeah, I was very happy with it. I'll stop ranting and raving, but hopefully this is useful for folks if you're looking to bind Python to understand maybe why not to go with PythonQt. PyBind is really great. I recommend it highly. I haven't used Boost Python, but I've heard that PyBind is just a lighter weight, somewhat more intuitive version of Boost Python. So yeah, there you have it. That's what I've been working on. I'm going to spend the rest of this week and probably a little bit of next week porting the rest of my code over, but I'm pretty happy about it. So it's a good time. Anyway, that's enough for now. Hopefully I'll make another video soon. I want to move back to animations. And thanks for listening. Until next time, folks.